Hello everyone, welcome back to my YouTube channel. Now I'm going to solve question number 3 of weekly contest 488. Count subarrays with cost less than or equal to k. So in this problem you are given an integer array nums and an integer k. For any subarray nums from left to right, we have to define its cost as max element in this particular subarray minus minimum element in this subarray into the size of window r minus l plus 1. We have to return an integer denoting the number of subarrays of nums whose cost is less than or equal to k. A subarray is a contiguous non-empty sequence of elements within an array. Now if you see the constant size is very large. Nums.length is from 1 to 10 power 5. So definitely I can't solve this problem in of n square. It will give me time limit exceed issue. And if you see nums of I value is also very large, 1 to 10 power 9, and k value is also very large, 0 to 10 power 15. So these are the constants. Just keep these constants in mind. Now here if you see this example number 1, this is your nums array. So how many different subarrays you can form here? You can form this one, 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 and you can also form this one. All this, I think in total 6 subarrays you can form here. Now in this subarray, window size is 1, window size is 2 here, window size is 3, window size is 2, window size is 1, window size is 1. And here max minus min element 0. Max is 3, min is 1. So 2, max is 1, 3, and min is 1. So 2, max is 3, min is 1, min is 2. So difference is 1. Here difference is 0, difference is 0. So here you are going to get 0, here you are going to get 4, here you are going to get 6, and here 3 to 2, right? This one. So here you are going to get 2, and here you are going to get 0, here you are going to get 0. Now less than equal to 4, here, 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 here. So in all these 5 places we have value less than equal to k. So output is 5. That's it. This is what you need to do. So there are 5 subarrays whose cost is less than or equal to k. Alright, so now we understand what we need to do. But I can't use here multiple loops, like first my I is here and my j is here. Then for this subarray, calculate the cost and check if it is less than equal to k. Then move your j forward. Then move your j forward. This is done. The next time move your I to this place and now start j from here. Then this, then this. Next time move I forward here, and then next time start from here. So here you are running nested loops. That simply means of n square. So this will give you time limit exceed issue. Now we have to optimize our code, right? So what I need to do here, if you see this particular example only 1 3 comma 2, so I want to find how many subarrays and at this position where my cost is less than equal to k. How many subarrays end at this position where my cost is less than equal to k? How many subarrays end at this position where cost is less than equal to k? So here at this place only one subarray ends. Now at this 3, this ends 2. At this 2, this ends, this ends, this ends. So this is what I need to do. Okay. Now in all these subarrays also I need to maintain what? I need to maintain the max value and min value. I have to find out that. Okay. And this I and j using nested loop, you can find the subarrays. But inside those subarrays also you need to find out max and min element. So that will also take some more time complexity, right? Which I'm not adding here. So all this stuff we need to take care. Okay. So what I can do here to optimize my code, let's do one thing. Let's maintain a DQ. So inside the current window, from left to right, I'm going to create DQ, let's say max D. It always keep the maximum element at the front. Maximum element at the front. And I will create one more DQ, let's say min D. It is going to keep the minimum element in the front. Clear this part? Now it is going to be very simple for me. How? So first time when I'm here, when my right is here, my left is still at 0. Let's say my left is at 0. My right is at 1. So at this particular position, my subarray ends. Right? Now I have to find out how many subarrays I can form here in this place. So here if I just give the indexing, so this is 0 index, this is 1 index, this is 2 index. Now here what we need to do, first we have to update the values in this maxd and mindi. So in my maxd I will store the index 0 because 1 is the max element I have seen so far, and in mindi also I will store 0 because 1 is the minimum element I have seen so far. Minimum element should come in the front, right? That's what I'm saying. Minimum element is 1 only at index 0. Maximum element should come in the front. Max element is 1 only. So we have just one element right now. Okay. So now in this case, this window, what is the length of this window? So R is at 0, L is at 0, and this is the formula to calculate the window length, R minus L plus 1. So window length is just 1. Window length is just 1 as of now. Okay. So now max element is 1. Min element that we have stored in the front, min and max both will come in the front only, na? So here let's say this is your max D, this is your min D. So 1 minus 1 into window length is 1, that is nothing but 0 into 1, that is 0. 0 is less than equal to 4, so just it is true. So in the result add 1. So in the result I have added this part. This is done. Now next time your R is going to move forward. So let's say your R is here now. Your R is here. Now in this case, uh, this is a new window, right? This is no new window 1 and 3, right? Okay. So now here in the max D, the max element should come in the front. So here we have 0. 0 is 0 means 1. 1 is smaller than 3. But here we need max element to become in the front. So here I will keep 3, just 3, and 3 is at I will keep 3. Wait, I will keep 3 here, and 3 is the max element, and 3 is at 1 index. In this I am just placing the value. Okay, this right value, this I have added. Okay, now after that here in min D means minimum element should come in the front. Okay, minimum element should come in the front. So previously we have 1, now we have 3. So 1 will remain in the front, but this time I am adding 3 also. Why I am adding 3? Right? So min element should come in the front, but here I am adding like this 1 comma 3. 1 comma 3. Why? Because later on in my code, if I shrink the window, right now I am taking this window, but so in the future I may start from 3 comma 2 like this, right? So in that case, or maybe if I have 3 comma 6, so I have to maintain this 3 as a min somewhere. Okay, if I have elements like 1 3 comma 6, let's say, so until here if I just keep the min element as 1 only instead of 1 comma 3 in order, so in the future when I'm moving here na, in this window, so in this window you will say 6, but 3 is also there na, so we have to keep. So that is why in min d I am just going to store the elements in increasing order. In max d I am storing the elements in decreasing order. In decreasing order. But But here I am not writing this 1, because later on if we shrink the window na, start from here, this one will never be the max element. This one will never be max element. But here when we shrink the window, this 3 can be the min element. So that is the reason I am doing it. Okay, so I hope that this part is clear. Now this is done. And here if you see, in max d you are adding 1, and in min d you are adding 0 comma 1. Here this time 2 elements, 0 comma 1. So this is how I'm just going to write my while loop. So we have to maintain the decreasing max dq. Here we have to maintain the increasing min dq. Clear this part? Now here this is done. Okay, now here if you see, the max element is 3, min element is 1 in the front, and the window length is this complete, r minus l plus 1 is 2. So 2 into 2, so this is valid. So if this is valid, so in the answer, in the result, you have to add this complete is valid. Okay, this complete is valid, in which we have min element also, in which we have max element also. If this is valid, so definitely this one is also going to be valid only. This one also going to be valid only. So if you move to this side, okay, if you just start from here in this case, so this will be removed. But see, min d is increasing na, min d is increasing. If this is removed, min d is increasing, so definitely difference will be much lower now. Difference will be much lower now. Okay, so here in the result I will add 2, these two. So I will add, ending at 3, I will add this part, and I will add this part. This is done. This is done. Now after that my r is going to move further. Okay, so don't worry, when you are going to see the code you will get more clear idea of this. When your r is here, now see this, your r is here. So now in this max dq you have to maintain the max elements in the decrease. So there will be no change here. There will be no change. Okay, 3 is the max, 2 is not the bigger. So 3 is going to come here, but is the max dq na, it's a max dq, right? This is max dq. Here now 2 is coming. Now 2 is coming in the future. So maybe you are like this 1 3 2 in 1. So now in the future if you start from here na, then you have to maintain the max dq. So now this time I am adding 2. Okay, this time I adding 2. So previously element I am removing. The next time when my right is moving na, I have to add. So 3 comma 2 I will add here. So here 1 comma 2, this is what I'm going to add. Okay, now here this time now see carefully what will happen. Now you have 1 comma 3, and now 2 comes. So I can't keep it like this. My main is increasing dq, so I have to remove this 3 first, because I'm taking this na, this complete window. In this complete window I have to remove this, and I will just keep 2. So here instead of 2 1 I will update it to 2, and here I will keep the element as 2. So this is how I'm going to maintain. In max d I have this 1 and this 2 decreasing, and in min d I have increasing 0 comma 2 index. Okay, and this is correct na, 1 and 2, 3 comma 2. Okay, this is done. Now here in this complete window ending at 2, so 3 is the max element and this is my min element. So 3 minus 1. Okay, 3 is the max element you have seen so far, and 1 is the min element into window length. Window length is 0 1 2 3. Window length is 3. So 2 into 3 6. 6 is greater than 4, greater than k value. So that simply means, right, what does that mean? That simply means that this is not a valid. Okay, so if this is not valid, so now what we need to do? This is not valid, this case. Okay, so in this case what I will do, I will simply, I have to shrink this. I have to shrink this window. So now my left is at 0 initially. Now after that what I will do, I will poll the positions where we have 0 here. So here I'm seeing 0 as of now. So I'm going to remove it. So left is 0. So our left is moving further. So definitely in this window, I have to check. So wherever I see 0 in the front, in the main D, or here if you see 0, so remove it. Na? Okay. In the first position if you have 0. Okay. So remove it. Other things we previously took care, but this time just remove it 0. Okay. So now this is what you have. So you have to remove this. Now max is 3, min is 2, and window size is this. So 1 into 3. Now this is valid. So now this is valid. Okay. So now if this is valid, so definitely this is also valid. Okay. So here, that is why we are adding this. This is not what we have to add. This is invalid case, so we move, instead of 0 we move to 1. So this is valid. Now this is valid. So these two things we have to add. Okay. So when I'm going to show you the code now, these things will be clear. But this is what I am doing here. Here all the elements are same now. So 5 minus 5 is always 0, and whatever the window length you are calculating now, if you multiply with 0, you are always going to get 0. So for any subarray of nums, the maximum and minimum values are the same. So the cost is always 0. As a result, every subarray of nums has cost less than or equal to 0. For an array of length 4, the total number of subarrays is 4 into 5 divided by 2. Okay, that is done. So for any array of length 4, the total number of subarrays is 4 into 5 divided by 2. So here how many total number of subarrays? 3 into 4 divided by 2, 6. So that's this formula I think they are applying, n into n plus 1 divided by 2. So this is how you calculate the number of subarrays, n into n plus 1 divided by 2. So this is the formula. All right. So this is done. This is what you need to do here. The only subarrays of nums with cost 0 are the single element subarrays. Just 1, just 2, just 3. Because k is 0, na? Right? So 3 is the output. That's it. Now let's see the code. So here if you see max DQ, min DQ I'm creating, result is equal to 0, left is 0. Clear? Now I'm running one right loop. Right is 0, right is less than nums dot length, right plus plus. And here we are just maintaining the decreasing max DQ. So decreasing max DQ means max DQ is not empty and the nums of max D dot peak last. So in the DQ we are just storing the indices. So max D dot peak last, and here nums. Okay, if this value, if it is less than equal to the nums of right, then poll last element, and in the max D I'm just going to add the last. That's it. And here in the this we are just maintaining the increasing min DQ. So min D dot is empty, or nums of min D dot peak last. If this value is greater than equal to nums of right, then poll it. Okay, and then add. So we are just maintaining the, just remember we are maintaining the decreasing max DQ here, decreasing here, and here we are maintaining the increasing, right? Okay, now we have to shrink the window if cost becomes greater than k. So while true, max value, mean value from the first you are getting this, and here length you are calculating right minus left plus 1, and here max value minus mean value into length if you do, and if it becomes less than equal to k, then simply break na. That simply means answer is possible. Answer is possible, and no need to shrink. Just directly come here and update the result. But if answer is not possible, then you have to whatever at left position. Okay, if peak first, if it is equal to left, then we have to poll the first element, or if it is equal to this left, poll the first element, and then left plus plus. So we have to shrink the window until this becomes valid, and then we have to add the result, and in the end we have to just return the result. That's it. So this is your code, and the time complexity for this one is just going to be of n only. It will not take much time more than this of n. That's it. Clear? So I hope that you guys are clear with question number 3 of weekly contest 488. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys next video. Thank you. Bye bye.